So we're looking at how to do writing equations for lines from a graph. And this is part of a kind of larger context where we're writing equations from lots of different things, either a graph or a point and a slope or 2 points and or a data table. But right now we're looking at how do you get the equation of a line for a graph. And if you know me, you know I pretty much hate this stuff when it's presented this way, because it's kind of like saying, hey, we're going to show you a bunch of flour and sugar and other butter and things like that, and then say, hey, this is pancakes. Well, it's not. It's just kind of the ingredients for pancakes. Pancakes are a lot better than that. So I like to at least kind of look at stuff and say, maybe somebody gave you a graph of a tricycle racer going across here, and you can see the number of feet they've gone every second and that kind of thing. And they ask the question, hey, can you tell me how far they will have traveled after any number of seconds? Okay, they're basically looking for some kind of recipe, some kind of pattern for being able to say, hey, in 12 seconds they will have traveled this far, or in 90 seconds they will have traveled this far. And what you're doing when you do that stuff is this: you're writing an equation, you're writing a pattern, and this happens to be for a line. Okay, so what we're going to do is look and say, is there a way I can predict how far this person's going to have gone after any number of seconds? Well, I do notice this. At 0 seconds, right here, they haven't gone anywhere. Okay? But after 5 more seconds, they've gone 2 feet. Okay? So I could say, hey, look, every 5 seconds, they've gone another 2 feet. So I could make some kind of a prediction that way. So I could do this. I could say, well, you know, at 10 seconds, let's see here. Let me write this. At 10 seconds, how far would they have gone? Well, let me figure this out here. We said every 5 seconds they went 2 more feet. So let's see. If I take that 10 seconds and I divide it by 5, okay, then that's how many times we've gone 5 seconds. So after, if I wanted to know for 15 seconds, that would be 3 5-second intervals. So what I'm doing is saying, look, here's how many 5-second intervals I've gone, and I will have gone 2 for each one of those. Okay, and then don't forget, we'd already gone 2 at the beginning, so let's add a 2 out here. So what if I'd gone 20 seconds? Well, 20 seconds divided by 5 is how many 5-second intervals, and then I would have still multiplied that by 2, and then I'd add the 2 over here. Well, I think I'm getting a pattern. If I take any number of seconds and I divide it by 5 and multiply by 2, that gets me how many more feet I've gone plus the original 2. Okay, so there's a pattern right there. We just wrote some kind of a pattern, and that's all an equation is. Now, what you'll see when people write this is that they write the 2 divided by 5 first. They'll say, look, take x and multiply by 2/5 and then add 2. And that's what y equals. That's how far it is. And then you might have looked at that and said, oh, wait a minute. I've heard this before. That thing is the slope right here, rise of 2, run of 5. And this right here is the y-intercept right there at 2. So, okay, so if they had gone maybe 3 feet every 5 seconds, we could just put a 3 right here instead of a 2. Okay, so we've managed to write an equation. Let me just write it plainly here, right in the middle. Y equals 2/5 x plus 2. And it may be, again, reminding you, this number right out front here was the slope, and this number right here was the y-intercept. Okay, so if I look at this situation here, the number of houses painted after a number of days, you might say, hey, wait, that's the same equation. Okay, and so we could say it crosses here at 2, so it's going to end in plus 2. The rise is 2 and the run is 5, so we've got 2/5 x, and then y equals. And what this means is apparently they'd already painted 2 houses, and then every day they paint 2/5 of a house. Okay, or 2 houses every 5 days. Either way you want to think of it. So again, the slope and the y-intercept. So when I look at this, hey, you know, this isn't going to work so well having houses painted and days, because hopefully they're not unpainting houses. That would be kind of foolish. So let's do this. Let's change the context here and just say, let's go back to feet traveled and seconds. And let's make this back to tricycle racer. Okay. Now, there is a bit of a problem. They apparently started some way down the track, and then they're going back toward the starting line, because let's see, this is 2, 4, 6. When they first started out, they were 7 feet down the track, and then it looks like 3 seconds later, they'd gone back 2 feet, and they were only 5 feet down the track. So they're going backwards. But that's okay. Here's what we're going to do. We're going to say, you know what? I understand this thing about the slope, the down 2 and right 3. So I'm going to write the rise of 2 and the run of 3. Okay, but they're going backwards. Okay, so what we're going to do is say, let's make it negative. Okay, so it's a negative slope. It means it's just going down. And then x is the number of seconds. And then plus 7 for the y-intercept, and there's your equation. So we're still writing equations, and the way you can think of it is this. The number out here, right there, let me change that to purple, number right there, okay, is always the starting amount, okay, and the number right here, which you get from the rise and the run, is always how the situation is changing. Okay. So if I look at another one, on some of these other types of graphs, let me just go to a blank screen here and get a graph made real quick. If I make some kind of a graph, and as long as you tell me what this amount is here, and you give me some information about being able to find the rise and the run, I'm good to go. So let's say it rose 5 and ran 7, and it started at 3. That's all the information we need to be able to write the equation. The rise was 5, the run was 7, okay, in front of the x, plus the y-intercept. Now, sometimes that y-intercept is negative. It might be down here somewhere. No problem. We just make this a minus right here. Sometimes the graph goes down and to the right. So no problem. Just stick a negative right here. Either way, make sure you got your y equals out front. And there is your equation for a line. Okay. So we'll get on to other types of finding equations here later on. I wanted you to see how to make how to find the equation of a line from a graph.